Here is a video on the study guide for the midterm this quarter. Here are the equations. You want to read these, make sure you understand them. This is the equation list for the test. All right, let's get started. First question: P1V1 equals P2V2. 4 ATMs times 8 liters is going to be equal to X, the pressure we're looking for, times 2 liters. Done. Next question, same formula, P1V1 equals P2V2. This time we're going to be in torr, 751 times 10 liters. It's going to be equal to X times 7.25 liters. Oh, I'm sorry. So for the next problem, we're looking for the pH, and we're given a hydroxide. Remember, that's OH. So we can't find the pH. We have to find the POH first, and then the pH. So initially, we will use POH equals negative log of the OH concentration. pH plus POH is equal to 14. If the POH equals 8.4, let's just go up here. The pH will be equal to 5.6, and that's slightly acidic. Next, we're asked to find the pH, we're asked to find the POH, and we're given a H concentration. So we're going to do the same thing but backwards. The pH is equal to the negative log of our H concentration. Therefore, the negative log of 1.94 times 10 to the negative 10th. So if our pH equals 9.71, well, 14 minus 9.71 is going to give us a 4.29 POH. And we're done. And remember, this means that it's basic. Remember, Ka times Kb equals 1.0 times 10 to the negative 14. If we're solving for Kb, that's equal to our constant, Kw, divided by our Ka. Remember, if now we're using our dissociation constant formula, Ka equals H plus times A minus divided by our acid concentration, HA. If we fill in our variables, 3.1 times 10 to the negative 4th, it's going to equal our H plus concentration times X divided by 0.2 molar. So now our question is, you have to find one of two variables, the X or the H plus. Since we know the pH is equal to the negative log of H plus, we can calculate that. So I'm going to do that up here also. Okay, I reset it. So here is our pH equals the negative log of H plus, and the pH being 1.78. Now I can solve for X as my hydrogen plus concentration. Negative 1.78 equals the log of X. And then to cancel my log, it's just an exponent 10 to the caret. That will cancel. Then my H plus concentration, what I'm solving for, is equal to 10 to the negative 1.78. .66 times 10 to the negative 2. Next, I'm going to plug that number of the H plus concentration into my original formula. Now that we have completed this equation, we can solve for X. And we get 3.73 times 10 to the negative third. Remember, this is our conjugate base, HCO3 minus. That's the concentration. Because it's a concentration, it will be in units of molarity. Here is Charles' law. V1 over T1 equals V2 over T2. And we're going to solve for V2. So we make sure we convert our temperatures into kelvins, 284 and 300 respectively. And we punch it in our calculator. Now we have, there we go, now we're done. Next we have the infamous ideal gas law, and we're going to be solving for temperature. PV over NR. We have to remember to keep our units correct, so we need to be in liters, atmospheres, so we can calculate the number of kelvins, and recognize what unit of R we're going to be using. .699 Kelvin, that's pretty hot. For the next problem, we're going to be using molality, which is moles over kilograms of the solvent. So be very careful with that, not the solution, the solvent. First step is to use 5.5 grams given, divide by the molar mass to calculate the number of moles of the solute. That's my numerator. Step 2 is to calculate the amount of kilograms of solvent. Given 200 grams of solvent, we have 0.2 kilograms of solvent. Now I divide those two numbers. And when I divide these two numbers, the molality is equal to 0.76, just about. Looking at this question, we have 45.8 grams of the solute and 375 grams of the solvent. When we add those together, we get the mass of the solution. So when looking for percent by mass, we're looking at the mass of the solute divided by the total mass of solution, the combination of the two, times 100%. That will equal 10.8% by mass. For the next question, we revert back to our ideal gas law, and more specifically, the combined gas law. With our combined gas law, we're going to calculate for P2, our variable. P2 is equal to P1 times V1 times T2 in the numerator divided by T1 times V2. Make sure that we convert our temperatures to kelvins, plug in our numbers, and we result in 101.81 atms as our final pressure. Again, here are the steps for the molality. 1. Calculate the moles. 2. Calculate the kilograms of solvent. And 3. Divide the two numbers. Remember, I divide by the molar mass to calculate moles, and move the decimal place to the left to calculate the number of kilograms. Now, I just divide the two numbers. 0.21 divided by 0.375, that equals 0.57 molality. For the next question, we are going to use the solubility of a gas, which is equal to the constant of the solubility times the partial pressure of that gas. we can multiply the two together to calculate the solubility of that gas. 5.6 times 10 to the negative fourth. Here are the steps for finding molarity. First, find the moles of the solute. Next, find the total grams of solution. Next, divide that by the density to equal the liters of the solution. And of course, our moles divided by liters is molality, capital M. Molarity, capital M. First, we divide 25 grams by 17 grams per mole to get 1.47 moles of solute. We add the 25 grams of solute plus the 250 grams of solvent. That yields 275 grams of solution. So we take the total mass of the solution divided by the density of the solution. That will yield us 0.296 liters. When we divide the two numbers, we will get 4.96 molarity, and we're done. I hope that helps. If you have any questions, come see me in class. Have a great afternoon or evening. And if you are up too late, go to bed.